Hello students, this is the equation of continuity in electrodynamics. Today we will discuss the significance of equation of continuity. We all know that equation of continuity is just the law of conservation of natural quantities such as the electric charge, the energy and momentum. We know that a conserved quantity which remains constant, it cannot increase or decrease as it transports from one place to another. So, the net change or the resultant change in the natural quantity inside any region of space will be given by the resultant of the amount of the quantity that flows into any region and that flows out of the region. Of course, that region is bounded. So, similarly, the equation of continuity in electromagnetism is just the law of conservation of charge. It can be expressed as dq upon dt equal to 0, where q is the total charge present inside any region, or on the global level it will be the total charge in the universe. But such a type of equation is not very helpful because our concern is not with the whole of the universe. Our concern is with the local circumstances. But the law of conservation of charge here applies locally as well as globally. Here we will study the local form of conservation of charge. Let us consider a region bounded by a surface S enclosing a volume V. Any variation inside the region of the total charge must be due to the fact that some amount of charges are flowing across the surface. The net change in the amount of electric charge in any volume of space is the resultant of the amount of charge. It is the resultant of two quantities. Some charge may be flowing into the volume and some charge may be flowing out of the volume. So the resultant is of these two quantities. Let Q in means Q inside be the amount of charge flowing into the volume between an interval of time, say between time t1 and t2. Similarly, Q out is the amount of charge flowing out of the volume during this same time interval. And what is Qt? Qt is the net amount of charge, is the quantity of charge in a specific volume at time t, which will be the difference of the above two quantities. This is also a representation of the continuity equation. Continuity equation, we should remember that it is applicable at each point in space and at every instant of time. Moreover, it is valid in all frames of reference. Let us now study the continuity equation in integral form. So consider a volume V bounded by a closed surface S. Inside the volume V there are charges. Now, as we have studied that electric current is just the manifestation of the flow of charges flowing across the surface. And the law of conservation tells us that any current flowing across the surface S will be equal to dq upon dt with a minus sign. We all know that minus sign comes out because the amount of charges inside the volume is decreasing. I is called the instantaneous current flowing outside the surface S into exterior space, and Q is any instantaneous value of the charge inside the closed volume. The minus sign, as I have told earlier, arises because a current is flowing outwards across the surface, produces a loss of charge within the surface. Now the current I can be expressed as the surface integral of the current density. So the net current flowing out of the volume I is equal to surface integral of J dot dA, where J is the current density. So if we put I equal to J dot dA in equation number 1, we get surface integral of j dot dA is equal to minus dq by dt. The charge enclosed inside the volume V can also be expressed as a volume integral of the charge density. This is only when the charge distribution is a continuous charge distribution. So dq by dt can be written as d upon dt of integral of rho dV, where rho dV is the amount of charge inside the small element of volume, and if we integrate it over the entire volume, we get the total charge. Now d upon dt of is a time derivative, and this is the integral with respect to the space coordinates. What I have done in this next step is I have put the time derivative of charge density inside the integral, because we know that the spatial coordinates or the volume inside which the charges are present remains fixed, and hence the partial differentiation with respect to time is appropriately put inside the integral. So surface integral of j dot dA becomes equal to minus integral of del rho upon del t dV, or using the Gauss divergence theorem, you can convert this surface integral into a volume integral. So volume integral of divergence of j dV becomes equal to minus integral of V del rho by del t dV. Combining the two terms, we get an expression like this, because this is true for any arbitrary volume V, and this expression divergence of j plus del rho by del t equal to 0 is the differential form of the equation of continuity. So hopefully this equation of continuity we have understood it. The significance of it is that it just expresses the mathematical statement of the law of conservation of charge. Okay. So this is a very short and brief introduction to equation of continuity, which will be using it in our later classes. Thank you.